Hey everyone, welcome to this Docker tutorial series. If you've ever wondered what Docker is and why so many developers love it, you're in the right place. So let's start with the basics. You might not be familiar with Dockerfile, images, and containers yet. Don't worry, we'll learn all about them. Just grab a coffee and let's keep going. Docker is a tool that helps you package and run applications in lightweight, isolated environments called containers. But wait, doesn't that sound like a virtual machine? Well, not exactly. Here's the key difference. Virtual machines, VMs, each have their own operating system and kernel, which makes them heavier and a bit slower. Docker, on the other hand, shares the host machine's kernel, making containers much lighter and faster to start. This efficiency is one of the main reasons Docker is so popular. But why do we even need Docker in the first place? Well, let's say you've developed an application on your local machine. Everything works perfectly, no errors, no issues. But then when you deploy it to a production server, boom, it doesn't work. Why? Most of the time, it's because of environment differences, different OS versions, missing dependencies, or conflicting library versions. It's the classic, it works on my machine problem. And trust me, every developer has faced this at some point. This is where Docker comes in. It allows you to package your application along with everything it needs, dependencies, libraries, configurations, into a container. This way, if it works inside the container on your machine, it will work exactly the same way anywhere else. No more "but it worked on my computer" excuses. Throughout this tutorial, I'll be using Ubuntu as my Linux distribution. However, you can follow along with the same command set on different distributions or even other operating systems. If you haven't installed Docker on Ubuntu yet, I've added a link in the video description. Check it out and get Docker installed before moving forward. First, let's check if Docker is installed on your system. Running the docker version command will show you the installed version of Docker. I will use sudo before all Docker commands because Docker runs as a system-level service and requires administrative root privileges. If my user is not added to the Docker group, I need to use sudo to execute Docker commands. If you don't see an output like this, go back and double check the installation steps. Now, Docker isn't just a regular program, it runs as a daemon, meaning it operates in the background as a system service. For Docker to work, this service must be running. You can start the Docker service using this command. It will either activate it if it's stopped or keep it running if it's already active. To make sure everything is working, you can check the service status with this command. As you can see, Docker is up and running. With Docker, you can run an environment that feels like an operating system. But keep in mind that this environment shares the host system's kernel. That's the key difference between Docker and a virtual machine. Unlike a VM, Docker doesn't boot a separate OS with its own kernel. Instead, it runs isolated user space environments. Now, to actually run something in Docker, we use the docker run command. But before we do that, let's talk about images, because that's what we're actually running. So what is an image? Think of it as a blueprint or a snapshot of an application and everything it needs to run. It includes system libraries, dependencies, and configurations. But an image itself is just a static file. It doesn't actually do anything until you run it. And when you run an image, it becomes a container. A container is a running instance of an image. It's isolated from the rest of your system, meaning you can run multiple containers without them interfering with each other. Now, where do images come from? We can create them using a Docker file, which is basically a script that defines everything needed to build an image, or we can pull pre-built images from Docker Hub, which is like an app store for Docker images. All right, now that we know what images and containers are, let's run our first Docker container. When running a container, we often want it to keep running in the background instead of taking over our terminal. That's where detached mode comes in. By adding these D flag to the docker run command, we tell Docker to run the container in the background, detached mode. This means the container will start and we'll get back control of our terminal immediately. Next, let's assign a custom name to our container using the -name option. Naming a container makes it easier to manage instead of dealing with randomly generated names. Now, what will our container actually do? In this case, we'll run an Ubuntu image and execute the sleep 300 command inside it. This simply means the container will start an Ubuntu environment and then stay idle for 300 seconds before stopping. All right, let's put it all together and run our container. When you run this command, Docker first checks your local machine to see if the Ubuntu image is available. If it's not found locally, Docker will automatically go to Docker Hub, the default registry, and pull the image from there. Once the image is downloaded, if necessary, Docker will use the image and run the container with the specified command, in this case, sleep 300. The container will start, and the Ubuntu environment will be ready to run the command. So, the key thing here is that Docker first looks locally, and if it doesn't find the image, it will download it from Docker Hub before running the container. To view the containers that are currently running, we can use a command that shows live information about active containers. Keep in mind that containers don't always have to be running. They can be stopped or inactive. So sometimes you'll see containers that aren't currently running but are still present on the system. If you want to see both running and stopped containers, you can use another command. To stop a running container, you can use the stop command followed by the container's name or ID. After that, you can easily stop the container. If you want to completely remove a container, you can use a command that deletes it by its name or ID. Now let's take a look at all the containers. As you can see, there are none because we deleted them. What about images? The Ubuntu image is still on your system even though there are no active containers. In a bit, we'll learn how to view images on your system. But before we do that, let's try running the Ubuntu image with different commands. Let's run the container interactively. To do this, we'll use the dit flags together. The -d flag stands for detached mode, which allows the container to run in the background, freeing up our terminal. The I flag tells Docker to keep the container's standard input sysdin open so we can interact with it. Finally, the -t flag allocates a sudo tty, which gives us an interactive shell. So when combined, -dit allows us to run the container in the background and still interact with it through a terminal. Now let's give our container a name with the --name option. In this case, we're calling it interactive container for clarity. And lastly, we're specifying that the container should run the /bin bash shell. This will give us access to a terminal session inside the container, allowing us to interact with it directly. So when we run this command, Docker will start the container in the background, name it interactive gar container, and give us a bash shell inside the container. All right, let's take a look at all the containers again. Our container is running in the background, but now we want to interact with it. So we use the sudo docker exec it interactive container /bin bash command. What does this command actually do? Well, docker exec lets us run a command inside a running container. The -t flags are what make this command special. I keeps the container's input open, and -t allocates a terminal for us so we can actually interact with the container. Next, interactive container is the name of the container we're targeting, and /bin bash is the command we want to run inside the container. This starts a bash shell, giving us an interactive terminal inside the container. To exit interactive mode, you can simply type exit. Now let's take a look at the images on our system. You can use a command to list all the images currently available. If you want to delete an image, there's a command for that too. But there's a catch. You can't delete an image if it's being used by a running container. So let's check out the running containers first. To do that, we'll stop the container using the docker stop command. After that, we can go ahead and remove the container using the docker rm command. But here's a handy shortcut. The docker container prune command will remove all stopped containers in one go without having to delete them one by one. So after running this, there should be no containers left on the system. Now let's try deleting the image again. This time, since no container is using it, we should be able to delete the image successfully. And that's it for today's Docker tutorial. We've covered a lot, from running containers to managing images and cleaning up your system. If you found this helpful, don't forget to hit that like button and subscribe for more tutorials like this. If you have any questions or feedback, feel free to drop a comment below. I'd love to hear from you. Thanks for watching, and I'll see you in the next one.